Okay, good. So I've got 3 more slides in this 6.7 just to study models a little bit more about modeling. And each of the models has a little twist to them. The first model was new because it talked about doubling. The second model was new because it talked about half-life, but it also had that extra formula nature to it. It was very formula-based problem. Now, this model is a comparison of 2 things. So there's actually 2 models here, and we want to do a comparison. So they all have these little twists to them. We'll take on this word problem. So we have a population of city A with 50,000, and it grows at 3.5%. Now, so sorry, I used the same numbers again, but with the 3.5%, but we'll run with it. Now, I'm not going to repeat that conversation, but because it's percent, it's growing by multiply, so we have to use exponential, and we get a choice because it does not say continuous. It doesn't say continuous, so I can use either one, a b to the t power or a e to the rt power. And I'm going to keep using this one. It's a little bit more straightforward. It's not as exact, but it's really close to the continuous model. And so let's make an equation for city A. Their population from their time. Now, we don't actually have a starting time, but we're going to assume that there's a starting year. Years, that t will be years after the start. So we had to have some start number. Maybe it was 2000, maybe it was 2015 or whatever. And we have the initial amount. So we have 50,000 people, and we have the growth rate. So we can get b equals 1 plus r. So I'm going to do 1.035 to the t power. So this is my model for city A. Now I want you to take a minute, and in your notes on your paper, wherever you're taking notes right now, I want you to write down the formula for city B. April. Okay, looks like just about everybody's checked in here. So that was kind of a test of yourself to see if you can do the model. Let's write it down so you can kind of check yourself. The initial population, 250,000 people, and the B number, we have to use that formula again. It would be 1 plus 0. Make sure you have 0.016. So that is our 2 mathematical models for the 2 cities. Now let's go to the question. Assuming the rates hold constant, will the population of city A catch up to city B? Any thoughts?
We equal the both equation and we find t.
Exactly. When are the 2 cities going to catch up? It's when the 2 equations are equal. So we're going to make these 2 equations equal. So we'll have 50,000 times 1.035 to the t power. And we're going to set it equal to the other equation to see when do the 2 cities have equal population.